So this is a recreation of my solving Advent of Code Day 3. I did this originally on the day itself, um, in bed under the covers using an Android tablet and emacs lisp. On that tablet, that's the Termux character emacs that I've been using. But when I solve it on the Windows 10 PC here, I try to solve it in such a way that I can run it both in um, Emacs and in Common Lisp. So the solutions are, conceptually much the same, but some of the details are different. Anyway, I'm going to start up an Emacs that I can use. And this Emacs starts up with a particular configuration, but I'm going to say I want a file called, and I have a function that takes the year and the day and sets up a template for me, um, where I'm going to put the input and the sample, and then where I'm going to write the code, and I have expressions to test it. So the first thing we need to do is get the actual data. So the idea here is that we need to collect each one of these digits represents a battery, and the batteries have to be connected in order, but what you want is to get batteries that uh, are connected in order of the two highest values. So any two uh, batteries can be picked, but they have to be sort of in this left to right order. And you want to pick out of the set of all of these numbers the two highest. So it says, so this is our example actually. So we'll take the sample and put it in. Uh, part one sample. The template has a room for a part two sample because there's sometimes, for some problems, it's different um, because the nature of the data is different. But rarely, most of the time, there's a single sample that's used for both part one and part two. And we need to get our actual input, which we can do this way. I am going to evaluate this. I think I already evaluated this, but it doesn't much matter. Notice I'm using single keystrokes to move whole expressions at a time, which is one of the great things about using elisp or Lisp in general for solving, you know, inside of Emacs for solving problems like this. Um, so um, what we're going to do is we're going to pick the top two. Now, because I've done this already on a different account, I know that the uh, part two usually is, a harder version of the part one. And in fact, when I did the solution on the day, part one's solution was very specific to just two numbers, but I'm going to have to pick more numbers in the next. So this is the general purpose solution. Uh, so another thing is I try to do the processing sort of in place. So instead of splitting up the string into pieces, which will cause you use up more memory for the pieces, and then parsing them into numbers, which will use up more memory for the numbers, I try to do it as needed and only as needed. So I'm going to say with start equals 0 to use the index into the input string that we're going to be working on. And the number of characters that we have to get that are adjacent is 2. Um, and then we're going to loop through the um, string and collect a list of the characters that are available on this particular line from which we can choose our 2. So, oops, I need one more. So for chars available, we're going to loop. The loop is a theme of this thing. For I from start below L, that's why we need the L. And so that means that the index I is going to be inside the input string character. For C equals aref input string I, so that's getting the character. For digit equals the position of that C in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if it's not there, then digit will return nil. Otherwise, we'll get the index, which happens to be the actual value of the digit. And while we have a digit, so as soon as we hit the new line at the end, we're going to stop because we won't have a digit. Collect digit. Sorry, no, not the digit. Collect the character. And then that's going to return the string of all the characters. Um, and then we're going to set the start to 1 plus I. So this is, I is pointing to the new line at the end. So 1 plus I is pointing to the, either the very, the past the end of the string, i.e. will be L, or to the beginning of the next line. And so now our job is, and at the end we won't have any. So on the outer loop, we keep going while we have some chars available. Oh, and the problem says we have to just add the um, sum of the selected uh, numbers uh, viewed as digits in a number. Um, so this is a little bit trickier. This next thing is for chars selected. So out of the n characters that we get on a line, we're going to have to loop uh, getting uh, the ones we want. And we're going to do it by uh, looking how many extra there are past what we need to fill up our string. So filling up our string indeed is 2 this time, but for part 2 we'll need it to be bigger. Uh, so we're going to do another loop. This time we're going to have a variable called answer equals. So this is going to start out being the right number of characters, but a list with the right number of positions, but each one filled with nil to tell us we don't have a character yet for this position. With source index equals 0. So this is the index from which we're going to be pulling characters. With LCA equals length of chars avail. This is how many characters we've actually got making up the line. Um, so these are all things, variables that are being in the scope for the entire loop. But each time through the loop, we're going to do for k below length of answer, So K is going to be where we're going to insert the the highest character we find. And we're also simultaneously going to collect how many characters we need. So we're n characters we need at the very beginning, and we're going to count down. And the range of possible eh, selections uh, that we can, find the largest digit from is going to go from source left, which is um, minus LCA source index. So wherever we are currently, after we pick the character, we'll have moved to the right past that character. And so however, and so that's where we're going to get new source characters from. So wherever we are up to, but not including the length of all of the available characters is how many characters there are left for us. No, that's the starting point, and the scan count equals 1 plus. It's going to be basically source left minus need. But we're always going to take one character because we're going down the available source characters one at a time. So source left would need when there's only the same number of characters available as we need would be 0. So that's what the 1 plus does, is it gives us one more. So now we're going to basically figure out what the max digit is and the new index for after that max digit. And haha, surprise, that's another loop. Loop with best and best index for KK from source index. Repeat scan count for C equals nth KK chars available. So this is in that range where we're trying to find the largest digit. Um, we're getting them out of chars available, uh, starting from the source index. And the character C is the one that we're currently looking at. When either best is null or greater the digit value, which we're going to always do as this, we have to do this because one of the difference between Emacs Lisp and Common Lisp is that characters are stored differently. In Emacs Lisp, they're just stored as numbers. In Common Lisp, they're special character objects. And in Emacs Lisp, you can compare them numerically, but you can't in Common Lisp. So, and moreover, the character comparison functions don't exist in eLisp. So if you want to write something that works in both places, you have to do something slightly uh, wordy like this. So when either we haven't picked the best one yet, or the current one is better than the best that we did pick, we set Q best to C and best index to KK. And then finally, we return the list of those two best, best index. And so then max and new index will become those two values. And so what we're going to do is we're going to set the nth to max. So setf is a common Lisp macro. It's a concept that you can't really do in other languages. Uh, it takes an expression here, which is the basically the getter for some structure, and it can be nested. That we could be doing the nth of something which is inside of a hash table, which is inside the nth of something else, or which is inside an array. All of those you can nest the expression, and what setf does is it turns it into the corresponding expression for doing a put of the lowest level thing. So we're going to store. In this case, it's the lowest level thing is pretty simple, but um, um, we're going to store the max character as the digit k in our answer. Uh, and we have to also do one more thing, which is we have to say source index is now going to be 1 plus new index. Notice when we returned best index, that was the index that we got the character from. So we have to use the 1 plus to go past it. Otherwise, we'll um, keep getting the same character. And guess how I found that out? Finally, we return answer from this loop. And we don't want chars selected. We want chars selected because that's the number of, it's a list of chars. Uh, answer is this, remember, answer is this list of nulls that we put in at first. Again, you can do things like indent the whole expression at a time. You can move forward the whole expression at a time. One of the reasons, and you can transpose expressions. One of the reasons that it's easy to actually do this with minimal amount of typing on a tablet with a on-screen keyboard. So that's the characters selected. So we have now for each given line are the ones. So now we have to do. So this loop is looping over the various lines. So we're going to sum up, um, and we're going to loop with a result, which is a number. So we're going to initialize it to 0. 0, I said. For C across course chars selected string. So the loop macro has many ways of iterating. C across means go through an array, and C will each time through the loop be the successive element of the array. We've used, for something in a list before that just goes down and gets successive values from the list. For D, the digit that corresponds to C, we use our circumlocution and position C in 0, 1, 2, 3, 4, 5, 6, 7, 8, oops, 8, 9. And then we're going to set Q the result um, by adding D 2 times 10 result. So that's accumulating the multi-digit value. And then finally, at the end, when we've accumulated it, we return it. And that should be that. So close that loop. So the, except that I did put it in the wrong place. This should be part one, sorry. Control meta E goes from wherever you are inside the function to the end so that you can then evaluate, and control X, control E um, evaluates it. So now we can try it. So in the example, we're supposed to get 98, and then an 8 and a 9, and then a 78, and then a 9 and a 2, and we add all of those up to get 357. So we're going to say control X, control E. So inconsistent naming, char selected. Yeah, I want chars selected. Again, control meta E to go directly to the end, control X, control. By telling you what I'm saying, it's slowing it down. It's very, very fast to actually do. And here, this time, I'm going to do control minus to give a negative numeric argument, control meta at to mark the entire expression, copy it to the kill ring. Now I'm going to use control U metacolon. This difference is if you do metacolon, you will evaluate and see the answer inside the mini buffer. But if you say control U, the answer will be inserted into the buffer. I'm going to yank in the expression I just did, and we'll see that the answer gets inserted, and it's the right one from the, so the same trick, control minus, control meta at, to mark the whole expression, meta W, control E, control U, meta colon, and that's our answer. And we will see if it's right. It's going to be right. As I said, I did this before. So, um, as I said, I've seen this before. So the second part means that now instead of using only 2 digits, um, you need the highest sequence of 12 digits. And that produces much larger numbers. And because I knew this, I did it in this way. So the trick that I always use for, I modify the part one function to have an optional argument. Part two, optional arguments in elisp always default, well, they default to nil if you don't specify them. Again, one of the differences between elisp and common lisp is that in common lisp, you could say open paren part two, some value, space some value, close paren, to give it a default value on the argument line. That elisp doesn't have that feature. But by judiciously using um, you know, the fact that it defaults to nil, then you can do it in both. And the only change is if part two, we need 12. Otherwise, we need 2. So control meta E, control X, control E. But then here we have to actually also, so that we've redefined the part one function so it can be called with an optional argument. So we will do input string t, so that now the part two function is going to um, call it with that optional argument. We don't have a part two sample that's different. Uh, Another thing is if you're in the middle of an expression, you can go control meta U to go up a level, except I typed it wrong. Control meta U, and then you can mark it from there with the control meta at. Control U metacolon. And what they say in part two is that's a pretty large number. Let's go back. and check if that's the right number. 312-191-077-8619. 312-191-077-8619. This is the same right number. So minus control meta at W control E control U meta colon, and we can do actually the same thing, minus control meta at to mark this. Gotta save this file and then paste it in here. And indeed, it is correct. Now, to show you that this, in fact, shall work, I'm using an inferior Lisp. This is a closure common Lisp. And oops, I didn't mean to modify it. Control X, Control F. One of the cool things about Emacs is that it preloads the history for you. So if you say meta n for getting the next thing in the history, except I said meta b instead of meta n, it gives you the file name. So then we can just copy that and say load. So notice it loaded file. The one thing in one change I had to make to Common Lisp is this requires CL. Is needed in Emacs Lisp to get the Common Lisp compatibility functions. Emacs has been renaming them and deprecating the old names, but I need to use the old names, otherwise this trick won't work. Um, uh, so in my Common Lisp, I had to put in the load modules place a single file called CL, which says provide CL, so that this um, would not get an error. Setq debug on quit in elisp allows you to use Control G to go into the debugger rather than aborting what you're doing. That's how you can do debugging of long-running things. You interrupt it. Use D to go. Evaluate things that and see how they're going. Use B to set breakpoints further up in the stack. You use C to continue. Um, uh, this is benign. There's no meaning to the variable debug on quit in Common Lisp. Anyway, what I wanted to do is not that. And then, in fact, that's why when I type Control G, I go into the debugger. But I can just continue, and it's the same way. It's just so. Let's see if we can make this. I'm going to put that on the kill ring. And then I'm going to put this on the kill ring. Go here and say list. So we're going to get both part ones and part two. And it completely works. Thanks for your attention.